everyone, and welcome to lesson 30.2. Today's lesson is starting on page 437 in your Springboard textbook, and you will want a pencil and a calculator. Today we are focusing on the area of triangles and different types of triangles and some formulas that we can use to solve those problems. You're definitely going to want to have your area formulas handy because you're going to add to the list today. Now, the area of a triangle is described as 1/2 the base times the height. So if we think back to what we talked about in the last lesson, we focused on how the area of a rectangle or a parallelogram was base times height. Today's is half of that. Now, why is it half of that? You might be asking. Well, here's our triangle, right? And the area of it we know would be this space inside. Well, think about it. If we took this triangle and we doubled it, it would be a rectangle. So it would be base times height. But again, we only want half of that. So that's why we are cutting it in half. Same thing with this isosceles triangle in example B. We would, if we doubled it, if we had two of the exact same areas, it would be an area of a parallelogram. So again, we want half of the parallelogram's area. So that's where that 1/2 portion comes from. Now, in these examples down below then for number 3, we have a bunch of different examples of triangles, okay? Now, the first example is a right triangle. And the nice thing here is the base and the height of our triangle are given because we have this base and we have this height. And again, the height is always where it's perpendicular from the top to the bottom. So for the area of this right triangle, if you know the two legs, you're going to be able to calculate the area. If you didn't, you would have to use Pythagorean theorem to figure out the missing leg. Okay, again, with the right triangles, you need the legs to be able to find area. So in this case, we're good to go. We would do 1/2 base times height. So half of 5 times 2, half of 10 is 5. And then again, we're dealing with feet squared on this one. The next one, if we're looking for the area of this particular one, the base is 2 feet. But again, you have to be careful about the height because the height is from the top to the bottom where it's perpendicular. So when we're trying to calculate area, which is again 1/2 base times height, we need the height first. So what we're going to do here is use our Pythagorean theorem to calculate that because we have the hypotenuse is 4, and then the base here of this red triangle, right, the right triangle, is going to be half of the total base length. The total base length was 2. Half of that would be 1 apiece. So we kind of have to sidestep here, and we have to calculate c squared equals a squared plus b squared. So our height squared, and then that base, which was 1. So we end up with 16 equals h squared plus 1. Subtract. We end up getting our height to be the square root of 15. So I'm just going to plug it in as the square root of 15 for now on this, just to, I don't need, you could put the decimal approximation. I'm just going to write the square root of 15. And then to get that final area, when we type this in, 1/2 or 0.5 times 2 times the square root of 15 gives us a total area of approximately 3.9 square feet. All right, last but not least, we have an equilateral triangle. Again, we have the base. The height is where things get a little tricky. So again, we know that we can use either Pythagorean theorem because this is cut in half, or remember this is a 30, 60, 90. So whether you would rather use Pythagorean theorem or the shortcut that this is just going to be 3 square root 3. Again, you could do Pythagorean theorem like we did in example B, but either way you slice it, the area is going to be 1/2 that base length, right, this full length here, which we know is 6, and then times the height, which is 3 square root 3. Or again, maybe you calculated, square root of 27, however you looked at that. But either way, when you type this in, you should get approximately 15.6 square feet. All right, now, one thing that we will see here is that actually equilateral triangles are going to have a special formula, and that is called, I like to call it the 2, 3, 4 theorem. And the reason I like to do this, and again, this is only for the area of an equilateral triangle. It has to be an equilateral triangle. But the formula would be side squared times the square root of 3 all divided by 4. Okay, so let's check this out with the example we had on the last page, where the side lengths on that last example were 6, 6, and 6. So if we plug this into the formula, we have 6 squared, so the side, S is the side length. So 6 squared times the square root of 3 all divided by 4. So if we type that in, 6 squared times the square root of 3 all divided by 4 would be about 15.6, which, if you remember from the last page, is what we got for our answer doing it the other way. So notice the equilateral triangles have their own special formula, okay? So let's pause for a second to make sure we write these down, right? We have, in general, the area of a triangle, and that's 1/2 base times height. You may want to draw yourself a little example here to remember what the base and the height look like for both the right triangle or just a triangle in general. You have the base here, and the height is always where it's perpendicular, okay? And then we also have the area of specifically an equilateral triangle, and that's specifically side squared square root 3 all divided by 4. And again, that's only when we know the equilateral triangle, that it's specifically an equilateral triangle, and again, you have that side length given. Now, some other examples we will see with this is we can also use the area of a triangle to help us figure out the area of our composite figures. So in the prior lesson, we did this with just rectangular pieces, but we also now can do this with triangles as well. So again, break this up into a couple different pieces. The first piece, if we look here, we have a rectangle. Okay, and this rectangle has a height of 4, and the base is going all the way from -7 to +7. If you count these boxes, you would get a total of 14. And 4 times 14 is 56 square units. Okay, so that's our red box. And then we also have one other rectangle who has a base of 2 and a height of 1, 2, 3, 4, 5. 2 times 5, we have an area of 10. Now we also have 2 separate triangles given. So we have a triangle here whose base is 7. Height, we said again, is 5. Right? Height on 5 on that one. So 1/2 of that base of that right triangle times the height of the right triangle. 7 times 5 is 35. Half of that is 17.5. And then last but not least, we have one more right triangle. This time the base of that right triangle is 5. Height we said was 5. So 1/2 of 5 times 5, half of 25 is 12.5. So the total area of our composite figure comes from adding those four together. The 17.5, the 10 of the rectangle here, the 12.5, and then of course the 56, right? We're basically adding up these four areas for a total area of 96 square units, or units squared. Now, one last formula that you will see is dealing with when we are specifically given a side angle side situation, okay? And basically what's happening in this formula, if we're trying to derive it, let's say we know angle A, we know this would be the height of our triangle, B would be the base, we would need 1/2 base times height to get the area. Well, in order to get the height here, we would have to use, going back to trig, 1/2 base times height. And again, that would be looking for these, we would have sine being used, okay? So what ultimately ends up happening when we rearrange and get this formula all good to go, we would see that to, again, get that value for the sine of angle A, opposite over hypotenuse would be h over c. And again, if we rearrange this, the sine of A equals h over c. If we want h by itself, we'd have to multiply both sides by c. So h equals c times the sine of A. And then last but not least, what's happening here is if we substitute in for h, this c times the sine of A, what we see is in this picture, to find the area of this triangle, and again, given side, angle in the middle, side, it comes out to be 1/2 side times the angle, sine of the angle in the middle. Okay, and again, this is for the area. And this is only when you're given side, angle in the middle, side, okay? So here we see that, right? We have side, sine of the angle in the middle. So make sure the mode is in degrees. Cannot stress that enough, that you want to make sure you're in degrees. You'd hit mode, scroll down, scroll over, and hit enter if you're not. Okay, second apps to get out of this. Again, on Google, whatever calculator you're using, make sure you have that. And for this example down here, my side lengths are 5 and 7, and then my angle measure is 49. So to get the overall area, you 1/2 side times the sine of the angle in the middle. So 13.2 square feet would be the measure of my area. Okay. One more example like that. Again, they're telling you on this one that this is 10, that B is 24, and the angle in the middle is 38 degrees. So 1/2 side, sine of the angle in the middle will give you your final answer. And again, as you type this in, 1/2 times side times the sine of the angle in the middle, which is 49. Oops, sorry, 38 on this last one. Excuse me. And we get a total of 73.9. And this time we're meters squared. Okay, so you'll definitely want to add this last one to our list, that the area of a triangle given side, angle, side is going to be 1/2 B times C times the sine of your angle, right? So if we have a picture here, it would look like this. Here's side B, here's side C, here's our angle. Okay. Thanks everyone for watching, and please make sure that you have these 3 formulas written down. Work more with these in class.